Alright, I thought for you I'd make a, short video on simplifying radicals. So we'll start off with just an example, and we'll do something pretty simple like what's the square root of 9? So what that's asking us is what number do I square? So what number times itself is 9? So hopefully this was a pretty easy one. We say, oh, well, that's 3. And we'll say that the square root of 9 is 3 since 3 squared is equal to 9. Okay. Let's try another example where I say, what's the square root of 100? So if you want to pause it for a second and think about it, you're asking yourself, what squared is 100? And you probably knew that it was 10. So the square root of 100 is 10. Since 10 squared is equal to 100. Okay? Alright, what if I do something that's not a perfect square? So 9 and 100 are perfect squares because 9 is 3 squared and 100 is 10 squared. However, 32 is a little bit more tricky. I don't have a nice number like 3 or 10 that I can just square and get 32. So this is a little skill that we'll use mostly for solving problems involving quadratic formula or something like that. But it might come up later also. So let's see what we could do. So let's see. Look at some square roots. So let's see what we. So square roots require 2 of. Let's keep having this go. Of a kind. So remember with the 9, we could have written it as 3 times 3, so there's your 2 of a kind. 3 times 3 is 9. So let's do an example with, I think I used square root of 8. Okay. And 8 is not a perfect square. It's not 2 squared because 2 squared is 4. It's not 3 squared. 3 squared is 9. So we have to do something else. And one way you can do that is you can use the factor tree. I'm going to show you a little bit of a different method here. So if I write the number 8 over here, so I have the number 8 written right here, and then I'm going to draw a vertical bar here, and I'm going to start dividing it by primes, so primes 2, 3, 5, 7, etc. And what's going to appear on the right hand side is going to be its prime factorization. So what we're going to do is we're going to take 8 and we're going to divide it by 2 and we're going to get 4. And if we can continue this process again, I'll divide 4 by 2 again and I'll get 2. And I'll do it one more time, divide 2 by 2, and I'll get 1. And once I get to the 1, that's where I'm going to end up stopping. Now this is the same thing as doing the prime factorization using the factor tree. 8 is 4 and 2. 4 is, I don't know if I'm going to be able to fit this in here. We'll try. Let's go ahead and erase this here. We'll try squeeze this in here. 4 is 2 and 2. Okay. And the prime factorization is just going to be all the primes there. So we have 8 equals 2 times 2 times 2. Okay. So in our problem working up here, so we're looking at this right here, I can rewrite the 8 as 2 times 2 times 2. So what I'm looking for is 2 of a kind. So you see how I have a pair of 2's there. That's if I multiply them together, I get 4. 4 is a nice perfect square. I know what the square root of 4 is. It's 2. So what's going to happen is I can simplify the 2 times 2, but unfortunately the leftover 2 has to stay put. So the pair of 2's comes out of the square root as 2, and then this poor 2 here, maybe we'll underline him or her, and if you want to give your number a gender, is stuck inside. So if you got 2 of a kind, then you can go ahead and pull out one of them. All right, moving on, let's do that 32 we were asking about. I'm going to go ahead and write out that prime factorization, and then again kind of mention going through it. So we went ahead and we wrote 32 here, and I'm going to start dividing by 2s, 3s, and 5s. Those are usually the smaller ones. You can also do the factor tree. I'll show you the factor tree of this in just a second. The one advantage of doing it this kind of a column method is you get your prime factorization right down the right column right here. So there's your prime factorization. It looks like we have 5 2's. So let's see, we divide 32 by 2 and we get 16. 16 divided by 2 we get 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. Once we get to 1, that's where we'll go ahead and we will say that's stop, and that's our prime factorization. I'm going to go ahead and draw in the factor tree, and you can see that we should get the same thing. So it doesn't matter which method you use. If you're more familiar with one, go ahead and use that one. You're going to get to the same prime factorization. That's one of the nice things is prime factorization is unique, so it doesn't matter how you do it. You're going to get to the same place. And we're looking at the prime factors, so we have 1, 2, 3, 4, 5. 5 2's the same amount we got in the column, so that's good. We got the same prime factorization. Okay, so I'm going to go ahead and write square root of 32 is equal to square root of the product of 2 multiplied by itself 5 times. So 2 times 2 times 2 times 2 with a square root on it. Okay, and I'm going to go ahead and underline I have 2 pairs of 2's. So we're getting a little crazy with the 2's here, but we have 2 pairs of 2's. So that means I'm going to be able to pull out 1 2 and a second 2. So those 2's come out as a product. 2 times 2 is going to be 4. Now, I had a typo here that I had to fix here, so I apologize. Oops, let's go back. Let's see. We'll go back. So I did have to fix this. I was having a moment when I was doing this problem. So this should have been a 4. So what happens here is, well, the square root of this 4 becomes 2. And let me get this thing out of the way. And then square root of this 2 times 2 is going to be 2 also. So that product there is going to give me the 4. And this poor 2, it's got to stay inside. Okay. So moving on, we'll get back to seeing if we can have this play. Let's go back. We want to start right here. Well, it looks like it's not playing through, so I'll just narrate this one. We're going to look at square root of 98, and so what we did first is we went ahead and wrote 98, and you can either do the factor tree or this method, and I did the prime factorization. And 98 is 2 times 7 times 7. I have a pair of 7, so a 7 comes out, 7, and then poor 2 is again stuck inside, so 7 root 2. Okay, and if we look at the last slide here, we're going to look at imaginary numbers. So if you took Algebra 2, you definitely would have seen the imaginary unit. I squared is defined to be -1, and the square root of -1 is defined to be I. So that's the definitions we're going to be working with. For us, there's really going to be a couple of sections in college algebra where we'll explicitly deal with imaginary numbers. One of them is a 1.3. We might see them again in, let me see which section that was in. I believe you might see them again maybe in 5.6, maybe in 5.5. Those typically are the sections where you will see imaginary numbers. Most of the time we will be keeping it real. Alright, so let's go ahead and practice simplifying an imaginary number. So I'm going to look at simplifying the square root of -9. Usually we would say there's not a real number because it is not a real number. And the way we'll break this up, we'll write it as -1 times 9. -1 times 9 is -9. I do that so I can kind of remind myself, oh, okay, well, square root of -1 is I, and then we already had a little bit of review. We established that the square root of 9 is 3. So what that becomes is I times 3. So the square root of negative 1 is I, the square root of 9 is 3, but usually we like to put the I after the number. So we write it as 3I. Okay? And I box my answer in. Let's try another example where we look at square root of negative 98. Again, we already simplified square root of 98. We just got the negative sign in there, so that's just going to add the I. But I will go ahead and write in negative 1 times 49 times 2. I did this a little bit different than the previous example. 49 is the same thing as 7 times 7, so 49 times 2 is the 98, and it's the same thing. So what's going to happen here is the square root of negative 1 is going to give us the I. The square root of the 49 is going to give us the 7. And poor 2 is, again, stuck in the square root, so there will be a square root of 2 here. So I, 7, and square root of 2. I kind of like to have the I after the number, but I don't like to put it after the square root because that square root has a tendency to cover up the I on accident. So I like to write it as 7I root 2 and not put the I after the square root because you have a tendency for this square root to kind of come off a little bit more than it needs to. Okay, I think I have 2 more examples for you. Let's do a sneaky little problem where they put the negative on the outside and they say, alright, well, what's this one? Well, if it's not in the inside, this just means this number's negative. Well, square root of 9 is 3, and then we just got the negative sign. So they're just trying to trick you. It's just negative 3. So we'll say be careful. All right, and one more real sneaky one. So we got 2 negatives going on here. The negative on the inside of the square root. Oops. Let me get this little negative right here. Now we'll give it a little red too. That one's going to tell us that we're going to have an imaginary number. And then the negative on the outside, maybe we'll do that one in a little extra emphasis. We'll make it a little blue. That's going to make our answer negative. So this negative on the outside is going to stay on the outside, and then negative 9 inside the square root is going to be 3i. So negative, and I'm writing out a little extra step. So I'll let this all go, and we'll go back to that slide. And so here's that negative on the outside, and we'll do that in blue. So that's just carried through. The negative 1 in the inside is going to become the I, and with 9 under the square root is 3. All right.